Hello, my name is Keshwani. This Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 643. Please turn to it, page 643, while I change the page number on the blackboard. 643, and today is our lesson number 65. Number 19 and 20 are the problems that we're going to do right now, and they are both classified as hard problems, which should not be a surprise to us because on a scale of 1 to 20, these two appear as the last two, 19 and 20. Number 19, in the picture above, the triangle XYZ, we are told, is an equilateral triangle with a length of 2. So here's the triangle XYZ, X, Y, and Z, and we are told that this is an equilateral triangle, and in it we see a circle which sits something like this. And the question simply is, what's the area of the circle? Now here's what's going to go on. In order for us to figure out the area of the circle, we need to know the radius of the circle, because the area of the circle is pi r squared. We need to know the radius. Well, we can figure out the radius very easily from the fact that they do not give this point a name, do they? Oh, they call it W. This is W, and this is 90 degrees, which is very helpful. If we look at just the triangle, if you look at just the triangle, here's what it is. We are told that this is an equilateral triangle, and we are also told, I believe somewhere in the problem, that one of the sides is 2. In the picture above, triangle XYZ is an equilateral triangle with a side of 2, which means this side is 2, this side is 2, and this side is 2. Okay, pay attention. And then they drop a perpendicular here. They call it point W. Because this side from X to Z is 2, which means X to W, because perpendicular bisects this X to Y, cuts into half, therefore X to W must be 1, and this is 1. All we are interested in this triangle. Watch here. All we are interested in this triangle right here. We have to find this side here from W to Y, because W to Y represents the diameter. W to Y is the diameter. Is the diameter of the circle. Once we have the diameter, we can take half of that, get the radius, and once we have the radius, we are home free, because it's just pi r squared is the area of the circle. So let's do it then, shall we? It's a simple application of Pythagorean theorem. Since this is a 90 degree, it's a right angle triangle, and therefore the square of the hypotenuse, which is 2 squared, must equal x squared plus 1 squared. We have to solve for x, obviously. So x squared is going to be 2 squared minus 1 squared, 2 squared minus 1 squared, which is 4 minus 1, which is 3, and therefore x is equal to root 3, which is the diameter of the circle. We just found out x to y is root 3. And therefore, this symbol means therefore, the radius equals half of that, root 3 over 2. Root 3 over 2. We are done. Area equals pi r squared. R is this, root 3 over 2 squared. And what do we get when we square root 3 over 2? Root 3 over 2, when we square it, the square of root 3 is just 3, and the square of 2 is going to be 4. So it's 3/4. It's just 3/4 pi. The area of the circle is 3/4 pi. Well, that's our answer. That's it. We're done. The answer is 3/4 pi. I hope you can follow my work here because I went all over the place, and the answer is C. One more time, very quickly. They tell us that this triangle that we have here is an equilateral triangle. They tell us that each side is 2, but they don't say each side is 2. It says what they say is It's an equilateral triangle with one side equal to 2. Well, if one side equals to 2, all sides are equal to 2 because that's what equilateral means. So x to y is 2, x to z would have been 2, and y to z is equal to 2. If x to z is 2, and because this line is perpendicular, they tell us that this is 90 degrees, which is the importance of this symbol here, that it comes down straight, which means it cuts the line x to z in half, which means x to w must be 1. If x to w is 1 and this x to y is 2, which in this triangle represents the hypotenuse, in triangle xyz, in triangle xyw, the side x to y is the hypotenuse. Therefore 2 squared plus 2 squared must equal x squared plus 1 squared, the square of the other two sides, sum of the square of the other two sides, and we found out that x is equal to root 3. Well, if x is equal to root 3, which is the diameter of the circle, y to w, therefore the radius must be half of that. Root 3 over 2, and it's just pi r squared, which is 3/4 pi. Let's do the next one, number 20. Number 20. Let's see what it says. It says when 15 is divided by a positive integer k, the remainder is 3. So we are told that when you divide 15 by some other integer, they're calling it k, we are told that when we do that, we get the remainder of 3. The question simply is, how many different values of k are possible? How many different values of k are possible? So let's find out. We want to divide 15 divided by 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. This is the easiest, simplest and the quickest way to actually tackle the problem. Don't try to do it in your head. Ask yourself, what are you going to get for a remainder if you were to divide 15 by 2? Let's make a list of remainder here. 15, if you will divide 15 by 2, 15 goes into 2 7 times with the remainder of 1, or 7.5. So the remainder is 1. 15 divided by 3, 15 divides evenly into 3, the remainder is 0. 15 divided by 4, what happens when you divide 15 by 4? Well, we're going to get our remainder of 3 that we're looking for, because 4 times 3 is 12, 12 plus 3 is 15, voila. So that tells us that the remainder is going to be, this part is the remainder here, the remainder is 3. So we found the first guy. 15 divided by 4 gives us a remainder of 3. And that's all it is. 15 divided by 5 will have a remainder of 0. What about 15 divided by 6? 15 divided by 6 equals 2 and a remainder 3. So here we get the remainder 3 again, which is the result of 6 times 2, which is 12, plus the remainder of 3. We found another one. So we found 2 so far. 15 divided by 7, you get the idea now, you got the pattern now. If you divide 15 into 7, it goes 2 times, 14, and then you have a remainder of 1. When you try to divide 15 by 8, if you divide 15 by 8, you get 1 and 7/8. 1 and 7/8, the remainder is 7. 15 divided by 9 is going to give you the remainder of 6. 15 divided by 5 is going to give us a remainder of 5. 15 divided by 11 is going to give us a remainder of 4. And what happens when you divide 15 by 12? 15 divided by 12 is going to be 1 and 3/12, or 1 and 1/4. But the point is the remainder is 3. So here we get a remainder of 3, which is a result of the fact that 12 times 1 is 12, plus a 3 gives us our 15. 15 divided by 30, 13 is going to have a remainder of 2. If you divide 15 by 14, you get a remainder of 1. And if you divide 15 by 15, it goes once and the remainder is 0. So we find 3 instances. Here's the remainder of 3 when we divide it by 6. Here's the remainder of 3 when we divide it by 12. So the answer is there are 3 instances when you divide 15 by a positive integer k, we get a remainder of 3. And those 3 instances are when k happens to be 4, 15 divided by 4 will give us a remainder of 3. Or when k happens to be 6, 15 divided by 6 is going to give us a remainder of 3. 6 times 2 is 12, plus a remainder of 3. And third instance, where we're going to get a remainder of 3 is when we divide 15 by 12. 15 divided by 12 is going to go into it once, giving us a remainder of 3. That's it. Those are the only 3 possibilities. That's it. That's where we have to stop. We can't do 15. We can't go do 15 divided by 16 because this is a fraction. It doesn't go at all. So there is no such thing as talking about a remainder here. Do you understand? That's it. We're done. The answer is 3. Answer is 3. C is the answer. Letter C is the answer. We are done with this section. I will see you tomorrow, where we'll begin section number 4 in this exam, which you will find on page number 650. Alright? Bye now.